चालू करो. चालू करो. रिकॉर्डिंग निखिल रिकॉर्डिंग चालू किया. बोल रहा. Hello, am I audible?
Yes, sir. Yes, sir.
Should I start now?
Yes, yes, please.
Technical team is ready. Hello, am I audible? Technical team is ready. Hello.
Audible. You are very much audible.
Okay, sir. Hello. Hello. Now we are beginning to start this phase 2 session. Okay. Now, good morning all. I am Professor Nitin Deshmukh, co-coordinator of Sttp phase 2 on the behalf of MCT's Rajiv Gandhi Institute of Technology and Department of Mechanical Engineering. Welcomes you all to AICT AQIS sponsored online short-term training program on recent trends in energy management and audit of phase 2. Let us commence this session with the introduction of our institution. MCT's Rajiv Gandhi Institute of Technology is a leading technological institute in Mumbai and Maharashtra, established in 1992. Institute is located on the shoreline of Arabian Sea. Institute offers 5 UG courses in mechanical, electronics and telecommunication, information technology, computer engineering, and instrumentation engineering. It offers 3 PG courses in mechanical, electronics and telecommunication, and computer engineering, and 3 PhD courses in mechanical, electronics and telecommunication, and computer engineering. Now, I would like to request the technical team to play the introductory video of our institute. Please, technical team. Thank you, sir. Now, I request the head of the Department of Mechanical Engineering, Dr. R.V. Kale, to brief about Sttp. Over to Kale, sir.
Hello. Hello. Am I audible?
Yes, sir. Yes, sir.
Good morning to all. Today's speaker, Dr. Tarapada Paine, our Honorable Principal, Dr. Sanjay Bokade, sir, Vice Principal, Dr. Sanjay Deshmukh, sir, all HODs, and the co-coordinator of the Sttp, Professor Nitin Deshmukh, and all the staff members and dear participants. Today, we are starting phase 2 of our Sttp, recent trends in energy management and audit, which is sponsored by AICT. The Sttp is being conducted in 4 phases. We are going to cover all the aspects of energy management and energy audit and its various application areas, which is almost everywhere. We are fortunate to have industry, the experts to give the talk, which are from industry stalwarts such as Dr. Paine, and people from power plant for this phase 2, Mr. Mantri, who is Vice President CNI at Dahanu Thermal Power Station, Mr. Asava, who is Vice President Operations at Dahanu Thermal Power Stations, Mr. Jalkote, who is additional vice president at Dahanu Thermal Power Stations. The number of participants registered for this STTP are around 150. I would like to appeal to all the participants to attend all the sessions and maintain the requisite attendance. I wish the STTP all the best. Thank you very much. Over to you, Deshmukh sir.
Thank you, sir, for enlightening us. Now I would like to request Honorable Principal Dr. S. Bokade, sir, to address the participants. Over to Bokade, sir.
Yes. Good morning, all of you. The guest speaker for today's session, Mr. Paine, Head of Department, Dr. Rajesh Kale, Co-Coordinator, Professor Nitin Deshmukh, all the colleagues of the department, all the participants who are attending this this program, either on the Zoom or through the YouTube link. I welcome you all on this first day of phase 2 program, first day of phase 2 session. So institute has been briefly introduced to you by Professor N.K. Deshmukh. So there would be no further introduction, which I would put it in front of you. So I welcome all the participants, and so far as the first phase, which has been completed, I congratulate the whole team for taking up this STTP through its phase 1 in a very excellent way. It was a great success. The STTP in its phase 1 ended well, and I expect that this phase 2 also goes in a very seamless manner, and there would be a good takeaway for all the participants through the various deliberations which will take place in the due course of time. I also thank our urging us to take the discussions on one of the most recent or one of the most prominent topics and needed topics, because looking at the scenario of today, the most essential thing which I could figure out is the energy, and energy coming to you from the direct sources like sun or everything else. And what is needed there, it's proper management, because utilization is getting happened tremendously. So management of energy, auditing of energy is something which is an essential aspect in the life of every mechanical engineer and all those who are concerned with it. So it's a good topic and excellent discussions, and we have excellent speakers also for the phase 2. So without taking much of your time, I wish all the participants a good takeaway from this STTP, and I wish all the best to the coordinator, Dr. Rajesh Kale, also the complete team of mechanical engineering who is handling this STTP. Thank you so much. Thank you so much. Over to you, Kale, sir.
Thank you, sir, for your guidance and support. Now I would like to take opportunity to introduce our eminent speaker of today's session, Dr. Tarapada Paine. Sir has completed his mechanical engineering from Institution of Engineers, India, Kolkata. He completed MTech in mechanical, dissertation in condition monitoring from JNTU, Hyderabad, and PhD in reliability management and knowledge management from BIT Mesra, Ranchi. He has served over 38 years in defense services, Indian Air Force, large process plants, petrochemicals, oil refinery, reliability management, operational and manufacturing excellence, rotary equipments, and energy management. Sir is currently working as a chartered engineer and certified reliability professional by CFR Chennai, and certified reliability professional by Ralliasoft USA. Also, he is certified engineer, energy auditor of BEE, Government of India. Also, he is certified vibration specialist immersion. He has more than 20 publications in renowned journal and conferences on his name, and a reviewer and editor of international journal on maintenance and reliability. Sir is a life member of various professional institutions like Society of Reliability and Safety, Navi Mumbai, Indian Association of Energy Management Professionals, Indian Institution of Mechanical Engineers, Mumbai, member of consultant of Saudi Council of Engineers, Riyadh, and Life Fellow of Institution of Engineers, India, Kolkata. I welcome you, sir, wholeheartedly, and it is our immense pleasure to be joined by you today. I request you, sir, to begin the session and enlighten us with your knowledge on today's session topic.
Thank you, Professor Dashmukh. Thank you for this introduction. I welcome you all, including Principal Bukhare sir, Kale sir, Professor Kale sir, Deshmukh sir, and all participants. Welcome here to our session today. I hope I'll try to share whatever possible in this very important topic today. In energy management, there are so many topics and so many discussions going on. Last time also in page 1 you have seen, and page 2 also covers similar topics. But today's topic a bit different in the sense the people doesn't talk this topic much. So that I want to touch upon today. And it is more than 100 slides. So I don't know whether I'll justify the time or not, but I'll try certain things. I'll push it up very fast, and if required, I may take little bit more time after 12. Okay, sir, because already you have lost half an hour because of introduction, which you are not aware of. And the first day it must be this. Last time in page 1, I started straight away. Okay, now I go to the presentation. Now, can you see my screen? Can you see my screen now?
No, sir. Please share.
Okay, because you have from there you have just disconnected
Please
me.
share your screen, sir.
Is it okay now?
No, not yet.
Okay, 1 minute. Please respond whenever I get some, otherwise it will be delayed. Is it okay now?
Screen.
Yes, sir.
Is it in presentation mode right now?
It's okay, sir, now. It
Yes,
is
sir.
visible and full screen also.
Oh, welcome.
Yes.
So today's program is on advanced reliability and maintenance practices in energy saving of critical machinery. Okay, that is the program today. And objective of this program, when you talk about reliability and maintenance, in energy saving, we always go for some technology changes or some procedural changes depending on our Energy Act, or maybe our requirement of ISO 50001. But we least care about it is minimum to see that maintenance and reliability of machinery have got a lot of impact on energy saving. We do isolatedly certain jobs, fine, but this is not done much. So I'll give you certain reliability maintenance concept, what is going on and how it is related to the machinery maintenance that we are going to share today. And what is the O&M scenario, latest operation maintenance scenario, a little bit, and how it helps our energy. So to know this, we must know asset performance first. If you know what is desired performance and its characteristics, how it is functioning, pump, turbine, compressor, whatever machine you take, and if you know performance, then you can relate where is the energy lost, how we can run this machine so that its performance is better, energy will be saved. So we need to know a little bit on performance characteristics, then latest tools on reliability maintenance, which is very vast, but I have to give you some input. Whoever junior faculty or some engineers, junior engineers attending this will be helpful for them. And reliability maintenance tools concept, then this is all about institute and industry, a collaborative effort to have a knowledge on this subject like any other subject. So that's also intention that we collaborate in talking, in consulting, in projects, in whatever way we should have a handshake in this. So what I feel that this is the ultimate objective of this program. So how I put the today's session is this is the way. I'll introduce the subject, then critical assets in energy intensive industry, and relative maintenance philosophy that saves energy, a little bit about it, and critical assets, how it function, performance card, little bit about affinity laws we discussed in the last session in the palms. Those who have attended, maybe they're knowing it. Then main assets, pump, compressor, vessel, very critical assets, furnaces, very critical assets. These are energy intensive equipment. So how they are maintained that way, and what are the problems comes in maintaining those, and how to tackle such reliability, energy issues. And brief on asset monitoring and energy monitoring techniques. Very brief. We'll go fast in the 5-6 minutes. We'll go on that. So to introduce, does maintenance has any impact on energy saving? Let's see the scenario in maintenance, because so far we know technology, either putting a VFD or making some adjustment on the process, making some minimum running of the certain equipment. If something is parallel, then you go for a one equipment or partial, or you choose like that way. So is it possible some saving in maintenance that we'll discuss? There's link or not energy. Then what are the knowledge scope we are talking about? At what level you can go for research in this type of topic? How we'll go for research? What are the things available all over the globe, including our India, and what are the institute offering such things that we'll can have some talk on this 1 or 2 minutes. Importance of energy efficient critical assets. What is the importance? And leverage maximum benefit of non-conventional energy assets. Non-conventional energy asset, we are thinking there is free, everything is coming free. No, everything is not free. If something happened to the wind turbine, your energy of that day or month or week may be down. Sometimes wind turbine is totally blown up by the sudden typhoon or something. So such type of maintenance, how fast they pick up, whether it is really maintainable or not, what is the maintainability, what is the reliability of such equipment that has got direct impact on energy saving. So wind is free, but our installation is not free. That's what we have done it in number of places in Gujarat, Andhra Pradesh, and all coastal regions, that these equipment are supposed to function 24 hours, 7 and 365 days. But anything goes on maintenance issue, your expected megawatt is lost. So that is the leverage. We have to leverage maximum, or we don't need to run those machines in optimum way. So that is the thing. So let's take a global view. What we are talking today, global view is such that industry takes 29%, and our buildings, all our buildings, office, house, all the buildings, FD, are at 31%. This is a little bit 2012 scenario, is not much change. So this is the things in a global scenario. And in this global scenario, we want to go industry. All over, not only India, and forget about any company, even top corporates. And maintenance means for productivity, quality purpose, assets. That's what we wanted, but it's not so. Maintenance, good maintenance has got wide energy impact, which you just forget to realize that. So operation and maintenance everywhere. So this is the view, and that's what in building also 5 to 10% annually you can save in buildings. We lose water, hot, hot water sometimes flowing. Okay, refrigeration, air conditioning, people not using, no one is in the room, but still AC is on. So such a building 55 to 10%. Okay, so this is the scenario, the global scenario. In this global scenario, we in industry 46% or so, around 40 or so, and in that pumps, compressor, which I've just told in the previous slides, we can realize through operation, maintenance, and efficient technology all the way. It is not that operation only, it is not the maintenance only or efficient technology only. You can save the energy in maintenance, operation both. So yes, savings can be realized through these. Okay, so installed capacity right now in India around 73 gigawatt hour. Every year we are adding 5 to 6%. We know that ministry how they are looking, and in this addition, 80% is generation from the coal. 80% generation from the coal, and captive power plant, because they're using gas and other things, it is 60% in coal. So 80% we want to reduce in next target, say 29 to 30 targets of government, that we want to have a target around this much, 50% almost. How will come? Our energy requirement is increasing, but we want to decrease our conventional source. So how we can do it? We can only do it. How we can do it? We can only do it by renewable energy. And we know that. We know that renewable energy can do, we can do whatever, we can put a plant, I can get the energy. No, there is a lot of operation maintenance issue more than in conventional plant. Because here everything free, but maintenance is not easy. Maintenance is very, very difficult for, once you put the solar power plant, it will give you, and it's not like that. So there is a lot of, if you just every 1 month, every 2 months, there is maintenance, regular maintenance done PM. So there is 10% growth in renewable energy. And this source has to be done by solar and wind. And if it is done, then we have to increase here. And here, this is how we can do. Does this operation and maintenance has any role in this increase? What do we want to expecting 50% here from the 80%? Yes, because it is maintenance intensive, non-conventional energy. Maintenance, wind turbine, nothing is other problem, only maintain. Once you put the plant, you have to maintain it and it will run, that's all. So wind turbine, 5 megawatt, 10 megawatt, 15 megawatt, so much capacity. You know what will be the machine? You can run inside the turbine. It's such a space is there. I'm not telling so much space, but such a big one. So, and such machine having problem, you cannot have the supply. That's the point. So scenario is like this. An Indian scenario, we are the third largest producer. Okay, and consumer also. Right now it was fourth. Right now it is third. We are the consumer also, third consumer and third largest producer of the electricity. And installed capacity, just now I told you, and per capita is only 1200 kilowatt per hour per capita. Means 130, 135 billion if you take and take it the entire energy consumption, then 1200 kilowatt hour. It is just 1/5 of the USA even. USA is taking a lot of, and so why carbon footprint is more there in the USA. We are not so much. So this is the scenario of India. In this scenario, we have seen 75% is the coal generation. So in this scenario, and coal generation, coal plant maintenance, whoever has worked in the industry, he knows what is the maintenance in the coal plant, coal generation, coal fuel, and power plant. So power plant maintenance so important, but operation maintenance we generally least care when it comes to energy saving. That's the issue I want to talk. Energy consumption in industrial asset, huge consumption. So huge consumption, if this, then there is opportunity also for saving. You are consuming more, that means you can also save more. Loss in improper maintenance, there's a major portion goes into this. So we have to think not only your energy bill, but equipment and efficiency. That's why I put this name 3 E's. 3 E's more important. 3 E's. That's I was discussed also in last page 1. The 3 E. 3 E's more important. And in this equipment, suppose take an example of a pump maintenance is 25%. So, and energy consumption 40% more on how we are operating. So you can see more than 50% and operation here, around 50% or so by proper maintenance of the equipment and maintenance of the pumps, we can save the energy. But we least care this. We think, okay, maintaining for production. Thought process is production. Total productive maintenance. It is not energy maintenance. Total energy oriented maintenance. Don't talk it because you are learned to have such type of thought process. We have to change this. We'll come to that. So small improvement, significant savings possible, and 75% of the energy by palms in industry. Because any industry you go, pharmaceutical, any everywhere palm, like chota ho, boda ho, kuch bhi ho. There are palms, palms, and palms everywhere. Last time, palm is our life. Last time I told you, everywhere palm. Okay, so there is a lot of, but you should know a little bit fundamental about it. Fundamental is what? Efficiency, equipment, energy bill. That's what I have to call. This is the fundamental to solve the energy issues. Means we want to save the energy. So this is three. Remember these three is. But barriers are there. There is initial investment. People will not try to invest on energy saving, but they will lose energy whole year. But immediate पैसा चाहिए तो problem है management को. So that's why initial investment is an issue. Knowledge gap is a big issue. Total knowledge management, opportunity identification. These are all the secondary benefit, but knowledge gap is there. Because that's why I was telling. So far, you go to any people who will talk on more on other issues. They will bring the best VFD high technology, okay, or the best efficient way of running the equipment. They will purchase, okay, or they will just bring, okay, bring ISO first, then we will see an equipment. They want system and process first. No, that will not work. Suppose you don't do any system, but you take care of the equipment engineering way, okay, so that time you will solve the real problem. Suppose you don't have any system in the plant, not a problem. Counting will automatically your production volume, your energy saving bill, reduction, all the things speak for you. So for that you don't need a system. System we need when we're quite good, mature enough. No, I want ISO first. This thought process has to change. Okay, so then only you can have more maintenance operation oriented saving. Okay, so that's my point. There is another thing I forgotten to tell. Yes, functional group are fragmented. Maintenance, the energy separate department. So I don't know how much link, maybe good company who is having really energy saving, getting award and all this, maybe good link. I have 1 or 2 cases from them. I'll show you that. And that's fragmented thought process in the industry happening, which maybe in academic, you may not be so much interacted with such type of things, but we over the time in decades we have interacted, we have seen how things are fragmented way is working, but we want energy saving. First of all, energy saving, I don't know, energy neither can be created nor can be destroyed, all the things are there, but why you want to have energy saving at all? Because you are committing mistakes while producing a pump, we are producing motor or the grinder machine or the fan, whatever. Why you have to make a stamp? Because you are creating problems. And why creating problem? Either our knowledge gap in engineering or specification, what do you want? All the things, the gaps are coming and kept into our system, equipment system, and we are creating problem. That's why you are talking energy saving. But there is things are there. For that only we have got all these issues because you have a now carbon footprint so much more than 2000 MTCOE by from India and maybe 15,000 other developed countries, and since you are putting a lot of CO2, and so we have thought now, okay, you have to energy save. But if you take more care on engineering design is such an important things for any thing. If you take care energy oriented view in the design, not that just go to the specs, put the formula and put the thing and okay, it is passing our quality control, all dimensional issues, everything, then we can pass the equipment. It will not work. We have to think in energy way how equipments are being manufactured. So what I meant to say, fragmented functional groups has to be deleted. We need to have interaction. That is improvement, of course. In some companies, improvement. I've seen in golf also there is a lot of improvement, interaction going on. So far, technology and management technology going on. Maintenance and energy are often studied separately. This is the so far thought process. Now we want maintenance must be used as a cost-effective strategy in any energy efficiency improvement program. If someone is coming to your plant or anywhere, first of all, you have to tell what is the operation maintenance you are taking care of. What is the system you're talking about? Where are the maintenance aspects of energy saving? No, ये होता है नहीं. It should be scientifically correct. It should be calculated way to be given to the management. This is the percentage from coming from these pumps. On, you can imagine in petrochemical, thousands of pumps are there, refinery, and thousands of pumps. One kilowatt hour, and it whole year, if you manage it, it will be sometimes maybe few lakhs, maybe some places in crores of rupees, just for pumps. Forget about other equipment. So such things are there. So there are studies, people have studied in China and other places, Japan, that productivity has got a link, maintenance got a link to the energy efficiency. So why you want to, this is the thing we want now, but how, why? Again, maintenance, health monitoring, energy monitoring, predict abnormalities. These are the maintenance techniques. So these are the techniques people are using for machine health, for the production. Thinking is that we have also worked in industry thinking such things, but we have not thought much energy way. People are aligning, people are making adjustment, people are installing. They are not thinking we want such and such machine to be installed on such and such date so that we get the 100% production on such and such time. This is the only target. So energy why people think while installing, while maintaining, so that are to come into the surface. Assist equipment management energy performance to desired level, acceptable level. Importantly, maintenance energy monitoring are less capital intensive than technology. We have forgotten the technology you bring, whatever money you put in the technology for energy saving, it will be much lesser in maintenance and energy monitoring and latest reliability maintenance tools if you apply. Okay, that people least care. Further, there are non-energy benefits also. Okay, safety and other things. So, excuse me, 1 minute. Mumbai municipality, they come up and they spray for mosquito. I don't know what is happening in the corona. They're very much after mosquito. Every week they come like this and they start putting this sound. Okay, so technology and management methods we are so far thinking. We are not thinking that maintenance of the pumps, and that's what is required. There is get link and maintenance everywhere: road, maritime, fuel, power plant, windmill, thermal, everywhere, household, everywhere there is a maintenance involved. Okay, if you don't maintain your refrigerator or your any other machines you are working with, and it will cost you more energy, which you don't see. We just see 3000 आ गया इस महीना में बस, बाकी कहाँ से हम हिसाब नहीं करते. That's the problem. So there is a lot of money is going available. If you can save from maintenance, good. Further maintenance is improving your reliability, availability of the assets. That will help the plant. Okay. So maintenance is the sole value-adding activity here in non-conventional, because anything happen here. Once you put, can you imagine type of turbine it is? Such a gigantic, so much bigger and so much kilowatt, maybe 15, 20, 30, 50 kilowatts, 15 to 20 kilowatts, and you see what will be the size of the machine. Anything happen in maintenance, thus that you don't get any power from that. So maintenance is the sole value-adding activity here. No other things will work here. So that is the thing. If you take solar plant, if you just put it without a maintenance, you see after 1 year all the panels, your range will be less absorbed. Okay, things will be totally. There is a schedule for this. So all equipment. Not only that, there are many other equipment attached to the solar. And here in hydro turbine, maintenance is the main issue. How you can get the hydro turbines, hydroelectric plants. See here, alignment is going on in the hydro plant. Here alignment is going on. Here maintenance and alignment is such a machine. It's a tough job. So maintenance, if it is not maintained, thing one turbine lost means megawatts lost. Like this, many other equipment, boiler, heat exchanger, similar things are built. So maintenance has huge potential. That's my point. So before you understand, we get an idea of energy saving from maintenance. Let us have some maintenance idea. What is all about? So maintenance certain practices we can avoid. Okay, adherence, we are thinking an outdated maintenance practices. We can maintain, but again, outdated maintenance practices we won't do. That's why reliability and plant ability latest things has come. So outdated maintenance practices, we have to forget it. You have to go to the latest practices. Less efficient, more power to produce same assets value reduction. Okay, assets value reduction. So if you take outdated maintenance practices, all the things, negative things will come. We want positive way of reliability maintenance, and wrong practices also continuous running. Sometimes AC is running continuously. Just 15% cost saving possible if you put it 1 or 2 hours, just stoppage, you can get it. Then if you something happen, then reworks, some breakdown is happening, reworks itself cost more than whatever it costed without any rework. 14%, 15%, these are all taken from study, different study available in the different companies. I'm not naming them. Okay, so why need to know reliability maintenance strategy of today? Because either our industry work is not connected to the knowledge, industry work what we are doing is not connected to the knowledge, or knowledge is not connected to the industry work. That's what we are discussing here in reliability maintenance strategy of today. So we all know maintenance. What is maintenance? Maintenance is how to restore a equipment to its original condition when it breaks down. This is simple way. These are all formula, other things for the students in class, but it is the only things. Once something fail, you have to retain it in shortest possible time. Shortest possible time in more availability of the machine, shortest possible time, right way of fitting the equipment, and we get the maintenance done. So that's the proper time and procedure has to follow. Standard operating maintenance procedure, SMP we call in industry. So maintenance is that. And there is evolution. This gap is available everywhere. We think about all of this. Earlier breakdown, then preventive, time-based, then this has come on condition-based, then it has come total productive maintenance. Okay, total productive maintenance, then reliability center maintenance, proactive maintenance, so many thinking, so many buzzwords has come, and people are trying to implement such initiative in industry, all process plant, steel plant, everywhere. Okay, so that's the way. If you go on top, your maintenance cost will reduce and reliability and availability high, green. Okay, so that is the idea, reliability, availability of the machine high, and here maintenance cost is very high in breakdown and preventive. This is the way. Evolution of maintenance, and costing part also takes care like that. So why maintenance? Because critical machines consume more power. That's why you are talking in energy. More power, critical asset, turbine, compressor, this more power. I told you compressor, you get just 10%, 15% of whatever 100 kilowatt you put, you get 15 kilowatt in your job. We know that. Whoever is doing energy, we know that. But rest other things lost, 80%, 85% lost. Then why maintenance? Best way you best engineering your machine, but it fails. Even best of the best supplier in the installation place just commission the machine, fail. 3 months, 4 months, again commission delay. Why? Because we are not perfect in engineering also. So there is a problem, lacuna. So even that's why maintenance we want to talk about, and we want to see in maintenance how best we can do power consumption less, because critical asset consumption more power. We have seen fan 7 megawatt, 10 megawatt, just ID fan. Can you imagine? Steel fan and all. So what will be the power if maintenance is not there? What will be the power consumption? It will be increasing. Alignment, machine alignment, unbalance, all the things will increase the power consumption. Such machine power consumption is very, very high. Cost of unreliability is very high. Knowledge gap risks, I told you there is always a problem. Cost of energy due to breakdown improvement is also very, very considerable. That is the thing you want to do. So certain thing, will go very, very fast within 5-10 minutes. All the things about this reliability maintenance, so that you can go into the saving part and different assets, saving parts of different assets. Because without knowing little bit on this, if you know, it's fine, good, refreshing. But if you do, some person who is not knowing about what is condition monitoring, people think so much talking all these things going on, predictive maintenance. It is nothing but look into the deviation of the machine parameters. If pressure, flow is okay or not, vibration, you okay or not, Is there any change or not? Temperature, is there any change or not? For that, either you can feel it visually, either or you cannot do it, then instruments you use, or if you cannot do it, different type of parameters have different instruments, and accordingly condition monitoring techniques also develop different way. If it is vibration, so we take in vibration instrument and its procedure systems, you call it vibration monitoring systems. If you take temperature or thermal imaging, you take as a sensing part, then you analysis part, and entire system you make it thermal imaging system, different condition monitoring technique. So ultimate certain selected parameters we measure. Why you measure? Because we want to know the deviation from the acceptable levels. Once you measure, you can then only you can see the deviation. So deviation from the acceptable level. Why you want to do that? Because present and future health of that particular asset we want to know. That particular equipment we want to know what is the present health and what is going to happen in future. That's what all about condition monitoring. That's all. Monitoring condition. That's all about the condition monitoring. So there are lot many things available, latest technology, because it is better to predict. Instead of opening the palms bearing at certain time, which we call a time-based maintenance, schedule maintenance, that is called preventive maintenance. Okay, that is time-based. Instead of opening certain things unnecessarily when it is good, it is better to predict कुछ हो रहा है कि नहीं, अंदर देखता हूँ कोई इंस्ट्रूमेंट लेके, अगर कुछ प्रॉब्लम है तब खोलो उसको, अदरवाइज मत खोलो बियरिंग को. अगर कुछ प्रॉब्लम नहीं लग रहा है, नॉइज नहीं लग रहा है, वाइब्रेशन नहीं लग रहा है, क्यों खोलना है? नहीं, 6 मंथ पहले उसको हम मेंटेनेंस के लिए टाइम दिया तो खोलना ही है एज पर द रूल्स. देयर आर मेनी इंडस्ट्री लाइक दैट, not required. That's why prediction has come into play, and that's why we call it condition monitoring or condition based maintenance, predictive maintenance, because you are predicting same thing. Okay, and taking decision based on the condition monitoring or diagnostic engineering, call it. Okay, so by diagnostic tools. Okay, so these are the called condition monitoring. These are very vast. Condition monitoring, vibration energy, we have just giving you a idea of what is all about. Otherwise these are all separate techniques. 1 week training also just for condition monitoring possible. 1 week. Okay, vibration monitoring 2-3 days, 4 days training is possible depending on the level of depth of exposure needed for the participants. Okay, so there are many techniques based on the different type of parameter. Oil vibration, oil analysis, wear debris analysis. Okay, ferrography we call it. Okay, so there are techniques are there. There is dedicated instruments, structure, all the things are there. All what are all these things? This is all for maintaining the equipment the right way, so that our energy consumes less, our productivity also increases. Super thinking productivity for all those things. But right now we have to think, or some people are already thinking right now, and there is a possibility that is already case studies are available where people have used this and got energy saving. Right, that's why I want to give you a little bit idea on this. Okay, so different vibration, this is thermal image, this is thermal image. There's a lot of possibility. Okay, energy consumption study, prediction of failure, detection of failure, all the things you can do. Means you are doing maintaining the machine the best way, because you know the oil before the failure, much ahead of it. And you can take a sudden failure will cost 15 to 20% more, maybe sometime some critical access 50% more than if you got some problem, open it and see what is happening the problem, accordingly change the bearing and all the parts responsible for the problem, then it will be much less maintenance cost. Okay, so, and why you want to study this? Because we cannot avoid this 30% increase next 5 years in CBM market, condition monitoring diagnostic market. Okay, and because of the industry 4, IoT, ML, everywhere people are talking about, so how predictive maintenance is going to help us in our diagnostics of these assets is important to consider. That's why you want to know this. You cannot avoid that. Education training very vital, which you are doing either industry, institute combined, or separately industry or separately in institute. That's education and training we do. There's a lot of possibility, research, PhD, MS programs on this field. Okay, so there are a lot of topics available. So who are interested, you can guide them, not an issue. So renowned institutes are available in India who are dedicated in this line. Okay, pretty and industry requirement is from 20-30% what is available right now, and many industry already crossed 30-35% in petrochemical refinery I've seen in Gulf. Okay, in some 1 or 2 company here in India, but most of the Indian company, this is very in preventive maintenance time-based zone. We have to go to higher zone of asset maintaining the asset to get maximum benefit out of it. Chahe energy ho, chahe production ho, whatever. And we need integrated way of approach. So while you're talking reliability, availability, what is it all about? Reliability means, am I reliable for this lecture? Or are the participants reliable? Means, are they listening properly? Are they getting benefit out of it? Is there interaction better way? Means reliability means fitness for the purpose. That particular purpose. What is the fitness? Okay, what is the fitness for the particular purpose? Continuing fitness for the purpose. Sorry, fitness for the purpose is the quality. That's it. And continuing fitness for the purpose is the reliability. So when you think about purchasing something, think about reliability, not the quality. Reliability takes care of the quality. Quality with time is the reliability. And if you take a good definition, then reliability means there is ability. There is uncertainty into it. And what is uncertainty? Means always less than 100%. It can never be 100%. Let it be any space research or whatever missile. It can never feel that 100% correct. No, there is always failures, and that failure will be 0.1%, something like that, whatever. So reliability picture, the probability has come into picture. That's why it is ability you're talking. Probability of happening something for a particular timing. That means, let us take a good definition. Okay, probability of an item or product or equipment so that it runs users requirement time in the particular environment, operating condition, maybe harsh environment, pura dhul pada hai. Okay, and that environment, okay, particular time, so that its mission time is completed. This is the way reliability is. What is the probability? Because there is always less than 100%, 90% reliability. Probability of success 90%. Probability of failure and reliability, okay, maybe 1%, 2%, depending on the equipment assets. Okay. So what do you know about reliability right now? Continuing fitness for the purpose, just thought process. That's all, nothing else. This is everything about the reliability definition. You study 10, 15 definition from different books, all will be saying like this. If they're not saying, I think we are not making justice to the ORM. Okay, reliability. So it is predictability. It is less than 100%. Okay, there is uncertainty. Then only we'll talk reliability. Otherwise not. If there is no uncertainty, there is nothing reliability talk. There is no statistic into it. Okay. So availability is what? Out of 24 hours, how much hours this machine is available? If it is 20 hours, then 20 out of 24 is the availability. And how you get 20 or 19 or 21? It is all about speed. You maintain this machine. That means it is maintenance related issues. If you maintain a machine pump, it takes 1 day for one worker or two workers. Okay, 1 day, but it's supposed to take say 1.5 days. Then its availability of this machine is will be higher. What I meant to say, how if you take less time, availability of the machine will be higher, because you are adding unavailable time to the available time. Okay, so availability, that is formula, study, other thing, reliability. We don't want to go into deep into this, because this is will take a lot of time, because our idea is now cost saving. So we not go, but idea we should know this. Maintainability, there is total difference in maintenance and maintainability. Maintenance is the task you are doing it, and maintainability is design concept. Maintainability. So if I tell how I can repair this, it is easily maintainable. Okay, easily maintainable. But if I tell the equipment, say computer, laptop, I cannot maintain it easily. So maintainability of this PC or laptop is very low, and this is very high maintainability. We can maintain it. So pump maintainability is higher than the turbine internal maintenance. So ease of maintenance is the issue. How easily we can maintain a machine. If this thinking has come into your mind, then you understand maintainability. So maintainability, any equipment is not maintenance. Maintenance is the task. Maintainability, how we can do? You cannot do anything wrong or right, increase or decrease. Everything done in the design. Same way in the PC also, everything done in the design. We have no other choice except major modification. So we cannot do it. So maintainability more or less cannot be changed except in design. So that's the thing, design issue. When we talk reliability class, that time we'll talk about it. So this is the bathtub car we all know all. Initially, any machine fail with infant mortality, and first failure is high, then over the time it decreases, then it has a random failure, constant failure quite a long time, and after that we are out failure aging process. This is equally good for the human, it is for the asset also. Okay, and there are certain things we are in maintenance. Certain maintenance issue we restrict consequence. Vibration monitoring consequence. Non-destructive taxi consequence. Failure pattern has started. We have no other things. We cannot stop that. Only thing कब टूटेगा वाइब्रेशन. अच्छा कब बेरिंग फेल होगा. ओके ये देखते 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 हमको 1-2 महीना में चलेगा कि नहीं. Okay, that is the thing. We are consequence monitoring we are doing, and chance there should not be any chance. If you look into that, that means we have to look into the design and that way of whatever thought process people have here put it, those things, proactive maintenance type of things to do. So why different type of techniques is given, whether you are measuring or you are interested to go into maintenance in consequence way or in chance way, which is good that you have to look into this. Okay, so there are cost reduction techniques, a consequence reduction, and there are chance reduction. And in the entire asset, all the asset will go through performance curves. See, different type of maintenance. If you maintain initial machine, then over the time, vibration, ultrasonics, all the things in this PF index, potential to failure, PF curve it is called, for any machine is important. So till it's back down. Okay, so asset condition in installation like this, and precision maintenance, laser alignment, other things you do properly, then your machine will run without any much problem longer. In curve will go like this. Properly aligned machine means less energy consumption. So this is the thought process of maintenance. Like this visual monitorings are there, just like endoscopy in our body we do. So visual monitorings are there. Okay, and visual monitoring of turbine part, internal part. Thermal imaging, we just take temperature of the machine and it looks like this. This is thermal image, this is normal image. And we connect. There is technology issue, instrumentation, no time to discussion of this, just gives an thermal imaging. You might have seen thermal imaging nowadays for corona in different airport. Okay, all thermal imaging only. And the same technique, same thing is going on. So here, high temperature you can find out, and that is after correction, low temperature you will get the low temperature 51. Earlier it was high 105. This is the white means 105, 1046. So that's the different way, mechanical application, all the application bearing, there is maintenance techniques, right? These things, if you do all in time, it will save your energy. This motor is running like this. If you keep on like this, it is taking more energy by way of heating, by way of misalignment, bearing damage, and all the things. It is taking more energy. If you count it, you don't count. That's why कुछ नहीं होता है, क्या आता है? चल रहा है 5 दिन से चल रहा है, change कर देंगे. No, if you count it, and number of motor in the industry, such as 1,000 motor, 2,000 motors are working in different plant for the pumps and other fans, then you'll see what is the energy it will go close. So there are different thermal imaging is been done in different places. Transformer, you see hotspot here and disconnected. After that, if you type, this is the original picture and it is thermal image. Okay, transformer. Oil analysis is a periodography. You take oil, then you take the oil for properties testing, and you take the oil for machine condition. How we come to know the machine condition? The oil visited certain places inside the machine. All those machines को कुछ wear particle है कि नहीं है, तो fluid में आ जाएगा, liquid में, and that is test in a laboratory and we get analysis. So this is also a very vast subject, just for giving you oil debris analysis or ferrography called. Most of the ferrous particles, so its name is given beginningly ferrography, but non-ferrous particle also get captured and we analyze. So you start from, suppose it's gearbox. Pattern analysis is important. Suppose it's gearbox. You start from here, then collection of the oil. After you prepare a ferrogram. This is a ferrogram method, like slides or blood test. Then you do put the oil from top. Here you put drop by drop, and all the particle will be captured here, and it will look large particle will be in the beginning, small particle is here, like this it will flow, and particle will be captured. How it will capture? There is a magnet under it. All these under this magnet is there. This is two simultaneously going on. This is like, so these things you get it. And after that, the same thing, this slide we seen under the microscope, scanning electron microscope. We call it in industry ferroscope because name is given like that. Okay. And after that, you get the picture like this. So different type of particle will give you different type of symbols. And from this symbol, from where this particle is coming, knowing the equipment, design, its parts, its component, we can find bearing. bearing है तो निकल क्रोम कुछ नहीं आ रहा है ना, सेप्ट ऐसा है, वो सोच के हमको ये सब देखना है. So skilled people are doing, there are many people are there, industry available, everything available. So things are there. I'll not go much on this. This looks like a paragram. And NDT, there are no number of non-destructive testing, radiography, ultrasonic, acoustic, diamond, the number of tests that are available for maintenance, latest maintenance. So anything parts, say what furnace cell temperature is ranging, getting, it should be below 25, 30, or maybe 60 or 70 degrees centigrade. But we are getting in certain place, there are 300 degrees centigrade. Inside temperature, 1500 electric arc furnace of the steel plant. So that much temperature, but in certain place you're getting more. That means energy is going past, plus this may have a hole afterwards. After sometimes we have to capture that by thermal imaging. Then when you correct it by NDT and other thing, we can correct it and you get the availability of the machine and you get energy saving also. So these techniques are very much in full. Magnetic particles also, they are magnetic. These are magnets. These magnets are used for particle. If there is some flaw, that flaw will create separate eddies, and that eddy you look like this, and you can get, and over the time when you do it, you spray a liquid along with the liquid or sometimes dry powder. Then powder we put and put this magnet, energize it, and you get the shape wherever the shape like this, wherever you have a fault, and you get the magnetic particle testings, we get the fault scenario, where is the surface fault, and the surface fault will appear like this. And accordingly, if you cannot visualize properly, you can put some spray, colorful, and the dye, and you will get this clear idea. And take a photograph, you can see what is given. So things are available. Magnetic particle, we will not go detail. Radiography, just like our X-ray. Here you use more on gamma ray in industry. So here in less exposure machine and like this, in X-ray also we take in industry for advanced technology for maintenance. Okay, acoustic emission, pressure vessel, anything happening, anything happening, creep going on. Creep you cannot see. So if you put the sensor, acoustic emission sensor, piezoelectric accelerometer, then you take different places and you will see different distance. You can find out what is the real time problem is happening over the months, years from this asset, which you are in doubtful, you think doubtful or important, critical. So the other thing available. Vibration is very common use. You use vibration monitoring in different equipment and different points. Every point there are three each horizontal, vertical, axial will take vibration. Why you take in 3 direction? Because vibration has got 6 degrees of freedom, and all the 3 directions you have to take. Okay, and from this vibration, for every type of fault, there is different type of characteristics. Misalignment separate, unbalanced separate. Accordingly, you analyze and you get the different. There is online system also vibration. There is on by analyzer also. So we take it system. All turbine, compressor, large compressor having this. Okay, so we get online diagnostics. So these are unbalanced issues like this one case, different places in a steel plant. So there is a unbalance and looseness both combined. This looks like this. I'm not going to discuss here on condition monitoring or diagnostic, but advanced maintenance tools are available to maintain the equipment that helps energy required. So critical asset motor energy saving 30 to 80% of total industry globally, if you see, and life cycle costing 92% energy consumption itself. Okay, 5% on capital, 3% exclusive maintenance, and 90% in energy consumption. This motor, if it is not maintained, I think this is only this is maintenance cost, labor, other things is done, spare other things. This energy much more can be reduced if you take proper electrical unbalance should not be there. Okay, eccentric gap should not be there. Bearing both the point of the motor should run properly. It should not be eccentric. There are a lot many motors we have seen eccentric in the bearing, and it gets a lot of energy more than what is supposed to take. Old motors, rewinding is common. Arey motor kharab ho gaya, winding karke le aao. More rewind, more energy consumption for that motor, because every time there are human errors able, you cannot wind the motor the way it was in the factory when it was shipped to you. So that is possible. So in large motor, about 20%, 18% large motor winding cost of rewinding, and 88% of the initial cost. Rewinding is done all motors. That is very dangerous for the very dangerous for the energy savers. Like you can detect these problems by vibration analysis. 70-80% motor problems you can find out. You can find a motor current signature analysis or MCA or PD, partial discharge, power quality, all the things you can do. There are a lot many techniques, other techniques are available in motor energy saving. Motor energy saving by VFD, there must be some caution. We use always very easily variable frequency dive, and you change the speed, and we are getting a lot of energy. But in that process, we damage the also bearing, because there is a high peak voltage available, and while very fast pickup, very fast down, very sudden change in RPM, all the things happening, and takes a lot of energy. And in that there is always spark through the bearing. If bearing is not insulated, this bearing will damage. You will create extra problem while taking VFD also into consideration. So what is the solution? There are solutions. These are the things happening in the bearing, common for all VFDs. But are the people are taking, or they're just putting a VFD on the previous setup? Then there will be a big problem. They must earth properly, and bearing damage, electro discharge machining should not be there within the bearing. So in the bearing, which is supposed to run properly, concentric way, is now running a machining. It is machining. Discharge, electric discharge machining is going on inside the bearing. Very tough problem, very serious problem. So things you have to, by insulating the bearing or earthing, it should be done. Now latest motor, if you purchase VFD, question them how it will better it is insulated. If insulated, what insulated material is taken? Is the casing is the separate material, or the bearing is the material? Will create a interaction and capacitance other issues or not? Check. You have to check it. So that is the thing. So you need to have judicious mixing of your thinking, putting in VFD. See, in VFD, fixed speed pump like this, and VFD this, we save this much, but this much saved should not create my motor itself problem. If motor, some HT motor, 1 megawatt, 2 megawatt, like this, plenty in power plant, mainly in steel plant and process plant, 1 megawatt machine, because of bearing damage and entire shaft broken, it will be crores of rupees production loss. So while saving energy here by VFD, you may damage the entire machine. We have to be cautious a little bit. So depends on, there are many things, depends on flow control, energy saving, different that we have discussed in pumps also last page, whoever attended. So there is a flow control. You can control the flow, you can save the energy. Okay, performance curves of the driven machine, all the driven machine, pump, compressor, anywhere, all the energy savings, how performance of the driven machine is. That's the ultimate criteria for energy more or less in the driver. If driver is the motor, then driver motor has to take consideration the driven machine's behavior. That means its pressure, flow, temperature, vibration, all the things to be taken care. So that's what performance curve of the driven machine. And system resistance it has to encounter. This motor, what type of system resistance a pump is encountering every time, every minute, has to be taken into consideration, because the system cars remain unchanged, but your performance cars will change depending on the performance. So that's the way energy saving possible on the different thing. So how big is the potential? In the potential of the pump, is it too much? That day also I told you, 800 pump manufacturer here, 18 billions worth, 16-18% growth in pumps, and all pumps everywhere in industry, IPM, all things, industry is full of pumps. There is potential of saving too much, and it is not saving. How will you save it? Maintain it properly, operate it properly. That is the only saving. If you cannot do, no VFD, no other thing will going to have a energy saving at all. This is VFD also. It is a timing. If you want to take, suppose you take a next project, think how many places you have put the VFD, so then the next project I will obsolete the VFD. I will take a right size palm, right size driver for the particular palm. So people should learn from the mistakes what they are doing. So BFD is not the only solution. BFD brings also, there are disadvantages. So here in industry, 25%, you see 95% are agriculture and building services pumps are used, and market share is almost 64%. A lot of potential for saving. That's my point to say, tell you. Okay, and life cycle costing we generally avoid in purchasing equipment, and that is a big problem. We see अभी कितना लगता है पैसा, कम लगा तो वही हमको परचेज करना है. A thinking also in procurement department. But life cycle costing now it has become so much talked about subject that people in procurement, the good engineer now, all procurement people, and nowadays companies preferring not the materials management managers or GDMM कर लिया तो उसको material में no, engineering background with exposure of such things, all this understanding, they will be better procurement engineer. So while technically they'll discuss, and LCC cost, life cycle costing is important. This initial cost of purchasing is very less, initial cost. Installation commissioning later on. Then energy cost is 2. How much is the energy cost? Operation cost, operational cost by putting in power, other thing and all things. Then maintenance cost, CM. These 3 things are to be taken into consideration. These are to be considered how, when you count is full life cycle concept. एक साल में 5 years के लिए आप सोच रहे हैं कोई भी इक्विपमेंट, 5 साल में आपको मेंटेनेंस कॉस्ट कितना होगा वो देखने का है. Not that he is giving warranty 1 year, 2 year and finish it. No, you have to take out the full life cycle cost. In that, as that is the thinking of the pump or any asset as such. If you only purchase your bike also like that. So in pump there is a lot of savings, 60% savings, energy and maintenance possible, around 80-85% gear pump support. Pump cycle 75 HP, see operating cost 55%. Here, how best you operate the machine, and operating machine. Why I'm talking about reliability? What is reliability? Reliability from the operation, reliability from the maintenance is all about the reliability. Maintenance reliability is not going to fail us. It is all about integrated system of approach. Integrated system of approach. Okay. Oh, okay. Reliability you put on percent, or you have reliability manpower, right? But maintenance you have not done. It's not going to help. So it is all integrated system of presentation in integrated system of presentation of your maintenance and production team. Okay, so here in energy and maintenance, the main issue you can see life cycle cost. It takes care energy and maintenance more. So here we can save lot many money. And let us take different type of design of the pumps. Pumps are different design: positive displacement, dynamic. These are not come simply. Over the time it is evolved. How it is evolved? Either maintenance has become easier, or cost of energy consumption become less, so energy savings, all the things has come into picture into design. So here is a flow creating device, different type, 2 types. Generally we divide in 2 types: PD and dynamic. We all know, whether it is in institute or industry, you all know. So these are the things. And energy, here is constant pressure. If we put generally positive displacement. Okay, for here in centrifugal we have a choice for pressure and flow. Okay, so that's the way we use dynamic pumps. Okay, so we, while putting the energy, you see less energy, more pumping we should get. So selection of the equipment should be like that also. Okay, so here in positive displacement pumps, if you see efficiency of the PD pumps around 98%. Mechanical efficiency 90-95%. This mechanical efficiency can be increased 1%, 2% increase, lot of saving by maintenance, proper maintenance. So here in centrifugal pumps, energy consumption itself 75%. So why people are more talking on reliability and maintenance issues on centrifugal pumps. And here main issue is pump impeller, nozzle, impeller eye. These are the 2-3 parts that should be taken into account in maintenance. Okay, so in centrifugal pump, how it works? Impeller eye, water is coming in the impeller low pressure, and you get more pressure while pulling out of the pump. Okay, so that an impeller vanes, it accelerates the fluids, and you get the higher velocity, and in the pump in diffuser section we get the more pressure. So that is the way in volute also call it diffuser. Okay, so this is the centrifugal pump, how it works. and this is the volute casing. And increasing area, what increasing area or increasing volume, you can say, is to the discharge. That is the impeller is moving. So this is the centrifugal pump in nutshell. 75% are used. So here, energy management core principle is energy management core principle. I told you it is all about our irregularity in performance. Means irregularity in its head and flow. Okay, that is the issue, and that is the issue means that takes care into science into this, and scientific solutions are possible by scientific consideration only. So scientific principle of fluid in motions are these all people have done for that. Okay, by knowledge, Newton, and all these people have done this. So we cannot have any solution as simple as that by any means without attacking to performance. Performance totally based on the scientific principle. So that's why core issue on energy saving in pump, compressor, anywhere is the equation of this equation. We are deviating from this equation while operating. And while operating, if you stick to this definition, best efficiency point, we'll never have a energy issue problem. Okay, and we always in engineering, if you take properly decision, take depending on the system cars at the curve in the field, we always you'll do better job in the manufacturing stage of the pump. So there are a number of efficiency, and there are these affinities law are available where by change of RPM, N is the RPM, and change of diameter, we get different type of flow, head, and power. And these are the things have to be taken into account. So energy saving, yes, it is all about hydraulic and fluid mechanics. Energy saving is nothing but purchasing some energy product or purchasing some VFD product and put it to the energy you'll save. No, even if you put the VFD, people are not taking care of these things in operation, will never get savings. And people will curse you. What happened? I'm not getting the things. I purchased all this. I've changed VFD. Why I'm not getting this? So that means we have to take care in the VFD. Driven machine is doing what? So driven machine has to do its job the way this formula demands. The formula demands. That's the thing. So this formula is like this. Displacement pump, it's a flow with coming like this, and centrifugal pump HQ curve is looking like this. And system curves, if you put either centrifugal pump or displacement, positive displacement pump for a particular system curve. What is system curve? कितना नीचे से पानी ऊपर लेना है, कितना दूर से पानी लेके आना है. These are our system resistance. The system resistance means साइट कंडीशन क्या है. तो वो साइट कंडीशन पाम का एक पुल है, पुल का वो बांध का ऊपर रख दिया, किसी ने नीचे एकदम पानी के सामने पंप रखता है. गांव में जमाने में हम लोग क्या करते थे, पंप को एकदम जितना नियर टू द वाटर पॉइंट लेके जाते हैं, सो दैट आवर हेड इज लेस देयर एंड मोर पंपिंग. If somebody is taking more height, it will not pump more. So things are there. HD and FD centrifugal pumps, different pump selections, and head and flow matters. And these two pumps has to encounter system curve. Now, system depending on the system curves and depending on the flow requirement and depending on the whole head requirement, you can choose which pump I will use it. Okay, so reciprocating pumps is very low head, high pressure, high head, low flow, high head के लिए, है ना, low flow, but high head, you can see like this. So system curve, these are called, this is system curves. System curves looking into frictional loss and dynamic loss. Frictional loss means dynamics loss and static loss. These two parts combined system curves. These system curves we get. I don't know how much time I get, then we'll go. 11:30. Okay, so no problem. So here you can see efficiency point, best efficiency point here somewhere where the HQ curve, this head and this side Q, HQ curve mid system curve is the best efficiency point. Okay, so in details things are given here. I have put number of slides here just to make you understand, and those are very junior, not aware of it, they can get this lecture later on also, they can see, and that is the reason I have put all these things. And whatever I have told in the pumps class there, I have some of the things I have kept for them only. So here same thing is discussed here, head and Q, and over the time is going, the centrifugal pump it is going down because more flow, head will be less in centrifugal. If you want more head, put positive displacement pump, not this. Okay, so like this internal loss, external loss are there in valves, in pipes, in bend. There is external loss. Internal loss, internal friction of the fluid motion, fluid in motion. Okay, so head loss and system curves looks like this. So static head characteristic of the specific installation. कितना ऊपर नीचे हमको हम पंप को फिट कर रहा है, इंस्टॉलेशन कर रहा है, इज द स्टैटिक हेड. एंड फ्रिक्शन हेड डायनामिक लॉस इंटरनल द internal pipes. Okay, dynamic loss, and that gives us this type of curve. As this is the system static head, how much height it is, and after that this is friction dynamic head. Okay, so these are dynamic head. Here static head is very less, dynamic is more. The different way of encountering in energy savings both. Okay, okay, so head and capacity, pressure head. If you change the pressure head, if you want to have a change in pressure head, you change diameter, number of impellers, size, shaft speed, you can change it. So you can change it, and that's what it is. It is good. We do not to change. We select a pump such a way we don't want to change afterwards. That's good engineering. When we are not able to good engineering or foresee our future requirement, but it is very bad for a plant. Today they're installing a machine, and within 2 years, 3 years, they want to go for VFT. It is not a good engineering, I say, because either you have not visualized what is requirement after 2 years, 3 years. Excuse me. So that is not wanted actually, but things are happening. They want energy conservation immediate. They have to reduce. Somehow they purchase the plant, put the plant immediate करना है, जल्दी करना है करके कर दिया. So that is not the solution. Okay, we have to do it. Even late हो गया. But in that case, you can do pressure head by all these things. Capacity, exit width, exit width of the impeller determined by capacity. Capacity is determined by that. So the more water pump, more energy also required. This is the element of a pump curve. This is the efficiency point, best efficiency point, and these are the maximum diameter. This is the minimum diameter. Okay, this much diameter with this efficiency. Suppose this is the maximum efficiency point is this specific due to point. Efficiency point is this line this. So this is preferred operating range is this. You cannot go any efficiency zone. Then again it will be energy issue. So we have to think about that. Which is the minimum diameter I will keep, because this power scale, you can see power almost same is going on. So I must get maximum power, a maximum efficiency with the minimum power. This is the power. And NPCH, this is the curve. Net positive suction head, we'll discuss a little bit later. So these are the different head curve, head and capacity curve, HQ curve, which I was telling you. This is the efficiency point, efficiency curve. This is the head capacity. This is a brake horsepower, increasing over the capacity, and here brake even best efficiency point. This is the point, best way it will run. Efficiency is maximum, and HQ more or less anywhere side you go, you are compromising the saving in energy. Okay, because this energy curve is there. If you go here, energy is more, but your power pressure requirement less. If you want more pressure, energy less, but your flow will be low. So our judicious judgment should be done. Impeller diameter, how it change over the time in efficiency is shown in this graph. Okay, and that means energy saving pumps, there are a lot of possibility. Maintenance and monitoring opportunity, controlling systems, operation, flow demand, design pumps, other efficiency, proper sizing of pumps, of all the things. If it is shipped, we have to proper size. That time it will come to the maintenance only. Okay, otherwise it is good if let take care by engineering group, and they give me an equipment which will have energy efficient. So parallel pumping, other things, these all maintenance issues and operational issues, impeller trimming, other things, velocity, all the things where you can energy save in the pumps. With clarity on performance curve, now we can appreciate and grip on energy saving. With no clarity on performance curve, means no clarity on scientific principles, mean total disregard to our all scientific principle, we cannot save energy by whatever means way. No sir, वो तो देखता है ना, जब हम VFD लिया हो तो taken care of. No, those people are much educated. Maybe somebody operating there in the field not so educated, he will be running in as per his own way. valve control करो, ये करो, वो करो. VFD लेने के बाद भी अगर आप valve change and reduction and control valve use करते तो क्या मतलब है? So all the things come into picture. So energy saving, there is a lot of link. And pumps we specify is important, and what is the system requirement is the important for the better efficiency. So these are the most inefficient way. Either flow control takes out our inefficiency, takes out our efficiency, or pumps we specify is not at the requirement, system requirement. So this is the problem. And pump in parallel, you can see pump in parallel. When you want more flow, put more parallel pumps. But we will compromise the certain flow, and certain flow we have to compromise, because if you put two pumps, almost double here, parallel system, two pumps. This is the parallel system curve. H over H versus Q. This is parallel system curve. The two pumps, 1 and 2, one pump is only here. This is the single pump. This is two pumps parallel. The two pumps parallel, you will see double flow. But in practice, you won't get it. You will get, because you have to encounter system साइट कंडीशन क्या है, वो साइट कंडीशन का कार्व है ए, सिस्टम कार्व. तो सिस्टम कार्व हम ऐसा जाके ऐसा नहीं कर रहे, we are not doing like this. System carve is same for the particular installation, but I have put two pumps. Okay, right? So two pumps, intention is double flow, will get double flow. वो सोच के लगा दिया, but in practice you never get double flow. Be careful, never be, because here system carve will determine how much more you'll get. Will get जो एक पार्ट में मिलता था उससे थोड़ा ज्यादा मिलेगा. So in between, maybe half, you can say half. So double नहीं है, 1.5 times मिलेगा flow. In series is different. In series, what happened? In series, adding their head. So when you pump water from some dam here in Mumbai and get it to Panvel, from Panvel another pump, another series, again means we want to keep the pressure head intact. So more pressure head, number of series connection you can do it. And in that, we are thinking about head increase, not the flow. Okay, so flow will be same, but we are increasing the head. So in two pumps, actually supposed to be 1 and 2 double, but you will not get double head. You will get less head because it will come to the 3 point, because it has to encounter system car. So it will come to the 3 point. So ultimately, even more number of pumps, you will get the pressure up to here, not this. This is all about parallel series operation. And how we operate for same system efficiency, or what is efficiency? System efficiency पैसा कहाँ से जाएगा? Maximum to energy. So you think it about that way. So parallel operation 2, and you can put 2, 3, 4, 5, but it will look like that. System is 1. You put any number, you can see how much gain you are getting by in the flow. You will not get 2 times, 3 times, 4 times. You will not get, because your system carb is not changing. Your system resistance side condition is not changing, right? That is the bit. This is all about in speed variation, how it takes care of speed variation. In for simple way, I'll show you the next slide. Okay, otherwise it will take time. So in speed variation, when you throttle, when you want to have a less energy with throttle, okay, or reduce flow. In that, what happened? From A point, it will go to the B point, and this system carb, which is 82% efficiency, it will go to the less efficiency, but you want flow less, 300, from 500 to 300 flow. 500 का pump है, but you want 2 साल के बाद हमको जब 300 क्यूबिक मीटर पर आवर लेना है, बिकॉज हमको प्रोसेस जो है वो प्रोसेस को उतना ही रिक्वायरमेंट है, ऑपरेशन पेपर बोलता है उतना चाहिए, तो हमको क्या करना है, हम थ्रोटलिंग करते हैं. So throttling करने में क्या प्रॉब्लम है? We are increasing the system resistance, and increasing the system resistance means you are increasing the frictional head more. This is the red curve. Okay, and static head remains same. जितना हाइट में है बस खत्म, उसमें कुछ लेना देना नहीं है. So system carb is increasing, and in that case A is supposed to be, and its system carb, it cannot go through this system carb, because if this system carb has to flow, we cannot change the flow. Flow will be here only. We want to less flow, so flow will go here. So flow will be 300 here in this point, and here in this point your system carb has been changed to this red line, and means what? You have gone against high pressure and you are losing so much energy more. Instead of doing more energy to this by throttling, put RPM less, because here this is the constant speed VFD, which you are talking about, VFD speed, and if we put VFD in lower speed, we get this carb, blue carb, and blue carb satisfy my system carb which is available at the site, right? So our intention of 500 to 300 cubic meter per hour is satisfied with less energy. I think it is everything clear now. So speed control is better than throttling always. Okay, that's what. Okay, because you have to keep, you see, system carb is bottom one, it has to flow like this. In an example, if you shift, what happened with the new point, it is coming 80 to 77%, and 300, you can see here it is, you have to encounter 42 mm head. Okay, here it is 82%, 70% efficiency point, and at 70 mm meter head, 70 meter head is 70 meter head, and here it is 42 meter head. If you go to the VFD, 42 meter head, so your head is reduced, means you are not using more pressure, but your pressure is not, maybe your process is satisfied, but your more important, your flow is satisfied requirement. And same thing explained here only. In, you can see 100 HP valve control, 15 HP lost, which is zero here, So here 75 HP motor will take care my efficiency requirement for the process operation, while consuming 15 HP less, and 15 HP kilowatt hour kariye, and number of month year and kariye आप कितना huge amount. And this is not the only pump, there may be many pumps like that, So pumps and energy saving, now we understand by using VFD, we can just put this carb dotted line up down. Okay, up down. So more than VFD, this is the best efficiency point. The blue, this is the blue one, and more up down depending on the, yeah. If you want to little bit more energy, but you have to put the flow higher requirement, you can always play with this. So that is the things he describes here. So in affinities law, nothing means how much affinity between the parameters. It is all about affinities law. And affinity law, we are trying to explain in unit level. Affinities law, you trying to explain what will be our flow, head, and power requirement when you change the RPM. So whatever thinking in the VFD, you cannot do whatever I feel like. This is controlled by this formula. RPM will be changed. You can change. This is the way. Little RPM change, your power requirement will be 8 times. Can you see this here? Cubic. This is formula is cubic. Scientific principle. So scientific principle will not allow you. This will be 8 times increase. So double the speed, power will be 8. So we cannot play whatever you feel like. We have to have full idea on this. And person who are in the field, they are very much aware of it. Engineer job, this, not the technician. Sometimes they don't bother. Engineer has to look into all the parameters. And good engineer of today, they are very much smart. They are from the place and they are attending lectures like this all over. They are going to industry. They always take care, sir, a problem ho raha hai. देखिए ना, this is the issue, this is the formula, then they will be appreciated also by the management. So you should think about that. And if you change diameter change of the pump, impeller diameter change, how it affects diameter change also equally horsepower like this. So we cannot see whatever you feel like. So little bit diameter change, power will be very less, 8 times it will be less. So if you increase the diameter, more. If you decrease diameter, your power will be less. So that way it is done. And impeller trimming effect is in the industry very rampant. and people are doing very easy. You have purchased a impeller 500 mm or a 500 mm, and you want to make it to some 400 mm, and within the requirement of the flow requirement, then you can do impeller trimming, which is very important, which is very important by changing the impeller. Okay, so that is frequently done, and I have cases also here. I'll show you. By changing impeller, you get the car from the beginning to the here, but you can see you are encountering same system car, not an issue. And after trimming, you get the reduced flow which you want, the desired flow. Okay, after trimming always about you want to have desired flow, but how easily I can get instead of changing the pump itself. So that's why people they want this. So this is done by trimming. So energy saving by trimming impeller. This is the case called condensate pump in a refinery in Gujarat. So they have done it. Initially, they purchased 550 millimeter diameter impeller and rated power of 160. And this 160 power with RPM 480, they need 100 and something. The refinery and the commission, they thought of this, but over the time they thought, no, this is not required. And costing and cost benefit analysis is showing the pump is showing more, purchasing a new one. Somebody raised hand, Mr. Sujit Kumar. Please tell if there is any question at the end. Sir, Sujit sir, please, what is the problem? Is he YouTube or with us now? Okay, I don't know why he raised question here. A question he has put a raised hand, whatever. So see, they want that from 350 cubic meter per hour to he want around 100 cubic meter per hour. Okay, so they've done trimming 500 to 470 trimming, and 10 to you cannot trim as much as you can in impeller. Then entire function and geometry, everything will be lost, and it will encounter a problem to the formula. So without going deep into this normal understanding that you cannot go more than 10 to 20% of the diameter reduction. Okay, so that is taken care. They've taken around 15 cubic meter per hour. Sorry, 15% reduction in the impeller dia. Okay, so energy saving in that process, the initial design was this, current working parameter is this, and current working parameter they're already getting less kilowatt, because 141 and on kilowatt here 99.8 kilometer, and current working pressure is this. Now they have gone into, and as per current working condition, power saving they're getting 53, but here they have done it by impeller dia changing to how much? Impeller dia changing to 470, and they got saving around 2.5. The unit rate is 2.5, and they get total cost of saving 13 lakhs per annum impeller. It is running. They're getting every year 13 lakhs. Because if they would run this in this diameter, then they would have lost this. Okay, this is a refinery case. I cannot tell the company name or things. So specific speed is another concept of the pump, by which once you purchase a pump, you direct take the specific heat. Depending on the flow requirement, you can get different type of pump. So you need to go for detailed analysis. Once you get a specific speed, and you can get the pump from the manufacturer accordingly. So here in the actually these are geometrically similar, different sizes of pump, geometrically similar. But if you tell the definition, unit volume, unit time, and unit head, there's nothing but you put one in this formula, and you get a specific head. Everything one means one. That's all. So we get specific speed like that. Okay. So in specific, we also affect the shape of the H2 car. That we have a separate performance car study on specific understanding. These are the dynamic element, not necessarily identical. So specific speed, why we want? Because different size pumps, how will fix? If specific speed 200, will go around Francis. If specific speed around 1000 or so, just go with this, and geometrically similar pump will give you for a particular flow on this radial vein. If higher specific speed, when axial flow high, axial flow type they will specify. So this is the understanding. The speed of pump independent of its size, so we have a specific speed, and formula takes care of it. So in system curve, that already I have told you, these are the two things. System curve. This part is this part. If this curve, system curve, sorry, this system curve, head Q curve, system curve is also head Q curve.
मला ते 1 वाला बघ, 1 ते 2 वाला मोबाईल वरती बघ. मग 2 नंतर किती
Can you please mute yourself? System head capacity curve. This system head capacity curve would have started from here 0 if no static head. Means यहाँ पे पानी है, पानी के पास ही हमारा पंप है. System head 0, static head 0, right? If you take the fluid pump, water. So the water. So near to that. So if there is height, then static head come into picture, and these are the dynamic loss. That's why you get system curve. And this point is the operating point, best of the efficiency point. So like this, most efficient in this pumping system, most efficient is the pump. Most inefficient is the pump itself, because it is mechanical part. That's why more inefficient. Other hydraulic, static head, other things, if you taken care properly, that is the more least efficient is the pump itself. So that's why we get hydraulic power always higher than the shaft power. Shaft power is always higher than the pump itself efficiency. So that if you take into account, this is the electrical input will be much higher than the shaft power, and shaft power will be much higher than the hydraulic power. So I don't know whether I have told correct way in the previous minute or not. Okay, so hydraulic power and shaft power, that's why efficiency come into picture. And in this efficiency picture, we put electricity, suppose 100 kilowatt, we get shaft power maybe 95, and accordingly hydraulic power flow, which is our efficiency point, flow, we get much less than that. That's the idea. So all these things at point efficiency point 60%. If this is the efficiency points, this is the best efficiency point 60%. You go any side, there will be efficiency loss. And in the efficiency loss, if you take 60% efficiency, hydraulic power Q head rho G divided by 1000, which gives around 9 kilowatt. Shaft power will be around 15 kilowatt machine driver you require. In drive you get 15 kilowatt, but motor power require 16 kilowatt, because everywhere there is a input output too much difference, whatever difference. Okay, so that's why efficiency, and that's why motor power is much higher. For a 9 kilowatt you need a 16 kilowatt motor with the efficiency 60%, and efficiency 50%, it is much more higher. It comes around 31 kilowatt. So instead of 16 kilowatt machine, we get instead of 16 kilowatt, we get 13 kilowatt. For 50%, we have to put a motor higher capacity, and loss. Higher capacity means loss. So we have to take care of the pump efficiency, and that is the things you have to understand the case. In cavitation, we get a lot of cavitation, in pumps. And somebody asking me, sir, can we prevent cavitation? It is possible to prevent cavitation if you maintain it properly, operate it properly. So there is always possibility. So absolute pressure at the inlet. See, this is all the definition about the cavitation. No cavitation means vapor pressure must be less than suction inlet pressure, and must be less than atmospheric pressure. That is the thing. And in this, these are the causes. Different. It can damage the entire pump internal blades, everything, and it should be always availability should be higher than the required. So pump inlet, whatever required here, it should be higher than the internal. That means whatever required here must be available at the atmosphere, and it should not go down to the vapor. If vapor here, then there will be bubbles form. And if it is bubble, then it is implode, not it is implode. That bubble will break. That is called implosion. Okay. Cavitation bubble implode, and because of this, this collapse. Because of this, first it will increase, then collapse. Okay, so in that case, lot of energy, and how this energy will go, it will impact to these blades, and it will आस्ते 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 erode हो जाएगा over the time. And it is so high. It is, हम लोग क्या सोचते हैं पानी जा रहा है क्या problem है? But if it is going, it is going to the vapor pressure, means it is hitting. It is heater. It is not a pump. It is becoming like heater. So it is spoiling the entire such a velocity. So that is the problem of cavitation. And this all the formula takes care Bernoulli equation and how it will become, and all this Bernoulli equation is applicable to this. Ultimate aim is available suction head. I'm not going to discuss here because we are not discussing only pump, so we will not go details. But you see, if cavitation pressure carry on decreasing, vapor pressure carry on decreasing, then your temperature is increasing 36. So 36 temperature, can you touch it? Okay, so you can touch, but 36 temperature you cannot go around Mumbai, so much hot. So 36 temperature like this, if change in pressure impact water temperature, and that is cavitation creation, and this cavitation creation is here and nearby. So we have to take care the inlet pressure is never always high than your vapor pressure. So vapor pressure should not go down like this. That's the formula tells about. Okay, so in a nutshell, this is a characteristic system design. This availability of the machine, system जब design कर रहा है तो availability उतना होना चाहिए. And availability requirement is a pump design. System of design में site condition जो हम सोच रहे हैं जिसके लिए pump, that is availability. हमारा pressure कहाँ से पानी लेने का है, ड्राम, लिक्विड, कूलिंग वाटर, टैंक्स कहाँ से लेना है पानी, उसका हाइट क्या है, all the calculation to be done. तो system design. So मतलब entire piping system design के time जरूरत पड़ता है. I require that pump manufacturer, he takes care design stage, engineering stage. Okay, so that is the thing. So availability should be greater than requirement to avoid cavitation, right? To avoid cavitation, this is the cavitation line. So avoid cavitation, it should be up, and whenever it is less than that, it will go down the cavitation bubble formation, and it will create. And what is affect? It will affect the entire efficiency, and it takes care of energy also. Total energy also will be more. You are pumping less. Low पानी नहीं है, but pump चल रहा है, and it is like a heater working. So avoiding oversizing of pumps, that we have told, oversize that we have already discussed in 500 cubic meter and 300 cubic meter previous example. Here we should not take oversized pump. That is the idea I already explained previously. Okay, so in energy saving in a power plant energy area, there is a number of stages they have taken a view, and a lot of problem was there in this pump, 860 kilowatt. Okay, the requirement is 50%. Can you imagine? Requirement is 50%. Can you start a machine like this? That means there is an engineering issue. I'm not telling wrong way to say somebody is capable, but we should think that we want 50% partial load, but you want a pump like, means total decision was wrong. But machine एक बार आ गया तो क्या हो गया, promoter we have to run the factory, right? So they initially put a VFD. So VFD is not the solution everywhere. There may be many other problems, electro discharge machining of the bearing, many other issues. So there is a problem in the vibration of this pump. When they are going to lower the speed, it is matching with the resonance frequency, means natural frequency of the structure. Okay, every structure piping will have natural frequency. The suction side is such, whatever it may be. So they were again changed to different stage pump, from 6 stage to 5 stage pump. And the 5 stage pump also there is a problem. So accordingly they some changes in the structural plates and other things and material, all the things they have done it. So in different case, 2-3 stages they got the benefit, and that benefit was 275 kilowatt. This benefit as the cost of, in a lighter side, is the cost of not selecting right pump. initially. So nothing to blame. They're getting right now this much less. Otherwise, they will use this machine, and this machine will create so much energy, 50% more than 50% energy loss. So they've got this gain. So reduction in power. This is good exercise, understanding the things, understanding the physics behind it, and all the things are understood. Fluid mechanics understood. People have done this job, got the benefit. But my point is different. My point is this: we should think reliability maintenance issue beginning from the design. Beginning means I am talking about the academic institution. Those are giving knowledge to the student, faculty, junior faculty. They should get the things over, along with the industry, that such things come should be taken care of in engineering, research and development stage. Okay, so then to my point, in that sense, that most energy saving opportunity and brains are available in academic institution, whether IIT, NIT, government institute, private institute, wherever they're thinking of a pump or any assets maintenance and energy saving issues. That's the point. We should be serious in thinking while transferring our knowledge to the student. And I always tell to students or whoever is listening that we are all from the borrowed knowledge. We are taking from somewhere and delivering to somebody. That's all our job. When we are doing something great or something extraordinarily new thing or breakthrough research, something, we will be recognized internationally because science cannot be wrong. So internationally, in that case, what I am thinking that we are all, there is no ego in this, because we are all in the same subject. Either you are teaching now, I am telling you, somebody taught you, or you leave the institution, somebody else will teach you, but nothing else different. Okay, so all are borrowed knowledge. So nothing ego in it. We should share our knowledge that way and get the things done. And academic institution is taking great role in this. Not that it is just for saying. It is actually. It is, because that's the thing. But people in industry, we have to tell them that you do something, we do something, there is a different theory and a practical, then become a problem. Because theory and practical, sooner you start differentiating, there won't be a solution. Solution होगा. Okay, so people think in industry academic institution वो तो पढ़ाता ही रहता है, teaching करता है, उसको क्या मालूम है. Or academic institution think, no sir, we need some practical exposure. Why? What is laboratory in this? Laboratory, there is a pump, you are taking all those things. What is different in that? If there is a difference, study the difference. There cannot be a difference in the scientific principle, and same person who is maintaining a small machine or large machine, philosophy is same maintenance, tool same time, it is following all performance curve. What is the difference you will do in the maintenance? So we should not feel afraid of the things and should not take the subject that way. Okay, in such any subject, not only energy saving or pump or whatever here. So, oh shit. So this is the pump they were talking, and they got the saving like this. Saving is too much, 72 lakhs per year. For industry, 72 lakhs per year, when they have to run like this continuously. Not that हमारा सोसाइटी का एक पंप खराब हो गया 10 दिन के बाद और किसी को बुला के कर लूंगा, ऐसा नहीं है. अभी आज के पंप ठीक है, और sometimes full day you cannot wait for the pump to open, start. So here savings is lot, energy intensive industry. In that case, sir, can I take up to 12:30 and finish? Hello, sir. Hello. Hello. Are you getting me?
Yes, sir. Yes, sir.
Can I take up to 12:30 because you have
Sir,
lost?
we have to wind up. Hello. We have to wind up, sir, in 10. Hello, sir. I'm Professor N.K. Deshmukh.
Yeah.
We have to wind up in next 10 minutes because after that second session will be start by 1 p.m. So please, sir.
Okay.
We request you to wind up in next 10 to 15 minutes.
Okay. So I not go any much details now. And maintenance, there are so many maintenance possibilities and lot of BFD. You can use soft food has a lot of energy. If you cannot maintain proper subfoot, then there will be energy issue. Then coupling alignment, every alignment is got a problem, and alignment has got energy saving, and in that alignment, misalignment, different type of misalignment. In that misalignment, we get 1 to 10% less consumption if properly misaligned. And this is there are studies are available. If 1 mm offset of a machine, offset means parallel misalignment, then you get this much power loss. So there are cases available on different alignment in 0.01, 0.02 mm, depending on the machine. Its limit. Okay, unbalance create lot of unwanted force on the shaft, and it takes a lot of energy. Okay, there are studies available, and that's why I want to precisely balance the compressor. One of the best severity of the issue of the compressor is 88% of the cost goes just production of 50% and leakage 25-30%, and in this production we use only 5 to 10% at the end of the user. Okay, so there is a lot of leakage, there is a lot of severity issue in this, and we know 6 mm aperture leaks any compression system, okay, is 5 lakhs per annum. 5 lakhs per annum. There are things available in books, in Bureau of Energy Efficiency, and there are things that are available. We can look into that. So much energy, but we very less care on energy saving in compression, which is the most wide scope in the energy saving in the compressor. Compressor and severity of the issue is very much. We get only 5 to 10%. So we have to awareness is issue, big issue, awareness. Leakage is too much. Nobody bother about the leakage, and leakage is not visible as long as it is not giving a lot of sound. People don't care about it. Forget about the equipment reliability. Okay, so survival kit is operation, how we maintain it, adapt latest technology in maintenance, and we have to meet carbon footprints 2030 goal for the energy, and international certifications are required, and inspection repairs are important. So past, present, future, how we do it? Over the time, people used from recip to has come to turbo compressor. However, there is less innovative things are available in the maintenance solution, smart sensing, other things, and no points of intervention. Where are the points where there is energy loss? Energy loss. All the points are to be monitored regularly. Okay, all the points. Okay. How to go about? We go either in maintenance practices or operational issues or maintenance installation aspect. Installation aspects, it can be 25 to 30% if you properly maintenance sorry, it is not installation, it is inspections. Sorry, leaks in the itself 25 to 30%. I'll change it afterwards. Okay, so this is the how do you go about system approach to saving compression loss. So in the system approach, again PV diagram and failures and fault, we have to maintain this, and we can get the analysis done by external agency or people are there who can do this PV diagram, and we can get how either it is a compression or suction, or if there are problems in the PV curve. Accordingly, we can get it. So performance curve should be that it should not go beyond surge limit, and it should not go above stone walling. Okay, there's a different thing. Who knows compression system, anti-surge system, they are aware of this surge limit here and stone wall. We have to run this machine within this performance curve. I not go detail into this because no time now. Not operating close to the BEP is a main problem. Either near to the surge point, we have to avoid. That's why generally common procedure derating of the compressor is done. It is more simplified way. This is surge line. Okay, so this is the something potential possible, and performance monitoring and health monitoring of the centrifugal compressor. There is online systems and online data is available, online knowledge available, and highly sophisticated maintenance systems are available. Okay, so need to respond to the system. How systems will respond accordingly, we have to respond also from the system when to take care that centrifugal compressor is going out of surge line and going out of stone walling. Okay, so that is the things we have to look into in maintenance. So the simple diagram of anti-surge systems. Okay, I don't go details into this. And everywhere possible, generation, transportation, distribution, everywhere we can get energy saving. Okay, generation also of the compression, transportation, distribution, everywhere it is possible. So there is a predictive systems available, the protective systems available, things are available. We have discussed that card, ultrasonic testings at different places with meter, and we can get what are the points of turbulence and energy loss. Then we can get the how much energy it can be calculated. Okay, so there is a calculation here, CF loss and different kilowatt savings per hour is given by fixing leaks. So leak detection, maintenance of this which is given. So here there is a compression steel plant. There also, I don't want to go into more, it is there in this, whoever is looking or may see the chapter. Now I want to, with this, I want to conclude here. Summary takeaway is this. It is all about awareness. Energy saving in maintenance is all about awareness. See, it is all about awareness. If we are keeping our energy and thought process to be on, and we have to think that lost every minute in operating and maintenance asset is huge. Is huge. You have seen in the compression loss and leakage. Okay, and change of thought process. So far, we are thinking energy means wherever there is a high temperature, energy is lost. No, we have to go to the cold zone. Our thought process has to go to the cold zone. Cold zone means maintaining. Where are the maintenance is wrong? Where are the operational wrong? Cold zone. So our thought process, let's shift it from heat zone to cold zone. Okay, so that's my point. I have just put it here for heat zone process. And indices, we are so much prevailing indices in all of our industry right now. We are thinking reliability center maintenance, total productive maintenance, preventive maintenance, predictive maintenance, asset performance management, asset integrity management, asset life assessment, all the things you are doing in maintaining the asset one way or the other, partially they are doing all the things for energy saving. But we need to think now in different way. Energy efficient maintenance, energy center maintenance, total energy efficient maintenance, or energy efficient design, energy efficient way we have to think it about. Even TPM, energy OE, is the energy oriented thinking for availability, performance, quality issues. Energy OE you are thinking, so energy OE or total productive, productive, total productive efficient or productive energy management that way, maintenance, total productive energy maintenance that way. So we have to think our thought process has to change. With this, I conclude here. Thank you very much for your virtual time. Thank you.
Hello. Thank you, sir. Thank you, sir. Indeed, it was a session filled with knowledge. Now, with your permission, I would like to begin the question answer session, sir. Should we begin, sir, question answer session?
Please
Now,
go ahead.
I request Professor Ratnam Gujar to start question answer session. Over to Ratnam Gujar, madam.
Good afternoon, sir. The first question is by Professor Rehan Siddiqui. It is, what are the latest energy maintenance technologies available?
Latest.
Energy maintenance technologies available.
That's why I told you energy maintenance is a huge predictive maintenance technology for identifying the different abnormality in the system. Like your different predictive technology means condition monitoring technology I was discussing. Okay, that is for maintenance side I'm talking. Don't think other side. Maintenance side, energy efficient is huge vibration monitoring system, huge leak detection ultrasonic system to leakage detection of the air compressor. Okay, huge NDT method, different NDT method available in this for static structure and all this. So those things will help you to identify all in time where is the wrong, where is the problems. So once problem is understood, we can repair there. Sometimes in the electric arc furnace or somewhere reformer thing, we don't know the which is the hot spot. So thermal imaging is done there. So once you get the thermal image, 300 inside 1500, external temperature come at 300, requires 75 or 80. So you understand what is the delta T. Once you get the delta T, we are all engineered to calculate energy loss, right?
Thank you, sir. So second question is by Professor Parmeshwar Kaur. How can we prevent breakdown? Are there any methods, latest technology available to prevent breakdown? And is thermal imaging can predict the breakdown?
That's why I think if he has attended my this session, I have told thermal imaging. Just a minute, I take. Can you see my screen or I have just left it?
No, sir, screen is not visible yet.
Not visible?
Not visible yet.
Just a minute. Can you see thermal image of this?
Yes, sir.
See, this is the spot. This is the very latest. How much? 1410, my dear. This is October.
Yes.
1410. This is suppose you don't attend it. What will happen? First of all, there will be reliability issue of this plant itself. Then thermal imaging, you can find out from our delta T before and after, and if it is happening, you can find out. No problem. Like this, many every day people are, there is nowadays plenty different application available, plenty all over in India, near to Mumbai, where you want to go and see, come, we can show you, no problem. All the substation, all the problem, the widely used thermal imaging. And nowadays thermal imaging, every Indian aware of it because of Corona. Every airport has got thermal imaging. What is 37 degree? Okay, go. If it's 39, 40 degree, you'll be captured and kept into the, okay, he has got Corona or something else. So things are available very widely. People are using it online also using. Okay. So things are available. Things are available. Sorry. I have shared it or not. Can you see this?
Yes, sir. Yes, sir. I can see that.
Okay. So things are available, not an issue. Please go ahead.
Okay, sir. Third question is by me only. Can we develop AI software for condition monitoring for predictions?
Is available. People are doing. Please see how people are doing algorithms, different machine learning and IoT platform. How they are using this tool, predictive analytics, and for the predictive maintenance. These are all predictive maintenance. You predict something, then you maintain, or it is called condition monitoring condition of the assets, or we call it diagnostic engineering. So once you these things are available, you can definitely do. We will be happy to. I can tell to collab with some researcher on this line, and you can do some study on that. Not a problem.
Yes.
Plenty available. Not a problem. These are the first time you are listening, but we are, it is our last 10-15 years we are nurturing these things.
Yes, sir.
Okay, do some project thesis on this.
Okay, sir. Definitely. Thank you so much, sir. So I conclude our question answer session. Over to you, Deshmukh, sir.
Uh, Thank you, sir. Thank you. I think all participants are satisfied with the question and answer session, and whatever the doubt they have got the answer of their doubts. Now I request Professor Mukund Walse to propose vote of thanks and conclude the session. Over to Mukund Walse, sir.
Hello. It is a privilege to propose a vote of thanks on this occasion. I, Professor Walse, on behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of Organizing Committee of AICT AQIS sponsored online one-week short-term training program, Phase 2, on recent trends in energy management and audit, and my own behalf, extend a very hearty vote of thanks to Dr. Pine, sir, for accepting our invitation as a resource person and sparing his valuable time with us. He has given a good insight on the topic of introduction to the topic, assets and energy consumption in industrial assets, energy links with the operation and maintenance, evaluation of maintenance, pumps and energy thoughts in design, and energy saving in pumps. Thank you so much for your valuable guidance, sir.
Thank you. Welcome.
Today on 23rd November afternoon at 1 p.m. we have the second session by Dr. Sandeep Doshi, sir, on the topic renewable energy in India and environment technology. Thank you so much, sir.
Thank you, sir, for joining. Now here we conclude the session, and thank you very much for joining all participants. Thank you so much for joining today's session, and we'll again meet at 1 p.m. for Professor S.N. Joshi sir's session. Thank you very much.
I request the technical team
Thanks.
to end the session.
Thank you.